Let's start our review for our final. And so I thought it would be nice if we went over what topics are going to be on the final. So the topics, first thing we talked about was integration techniques. So this was in chapter 8. Then we did series and power series. That was chapter 9. Then we switched back to applications of integration, which was chapter 7. The very last topic we discussed was polar and parametric, which was chapter 10. And so for these review videos, I'm going to focus on the earlier topics that we discussed. So 1 and 2, that's going to be my primary focus. And we're just going to start doing a bunch of problems. So let's start with our first one. Let's evaluate the integral of t to the 4th ln t dt. So here notice that we have a product of two things. So we're going to use integration by parts here. So just as a reminder, we're going to use integration by parts. The formula u dv, u times v minus v du. So when we do integration by parts, we make a little chart or table. And you're going to split it up into something that you take the derivative of and something you take the antiderivative of. Remember, whenever you have a natural log, which we do here, this always goes in the u spot. So then everything else will go in the dv. And we fill in our table, take the derivative of ln of t, take the integral of t to the 4th, then remember that you go across and then diagonally down. So the integral that we were given, you multiply across, so ln of t times t to the 5th over 5 minus the integral, and then diagonally down. Okay, and now we're going to simplify. Ln of t, t to the 5th over 5 minus 1/5 t to the 4th. And now we no longer have a natural log function there, we just have a polynomial. So do the reverse power rule here. Minus 1 over 25 t to the 5th, and don't forget the plus c. Let's look at our next problem we're going to do together. Let's evaluate the integral of t squared e to the 2t. So again, we have two terms here being multiplied, t squared and e to the power of 2t. So we're going to use integration by parts here. So the e term could go in either position, but we have this polynomial here, and so we're going to put it in the u spot, because what happens when you put it in the u spot, the power goes down. So we're going to fill in the rest of our chart, take the derivative of t squared, take the integral of e to the 2t. You'd use a substitution to get that. And so the integral t t squared e to the 2t. Again, you go across and diagonal. T squared e to the 2t over 2 minus the integral of t e to the 2t. And so now here's where you should stop and compare. What did I start with? And what do I have now? What's changed? The power of t went down by 1. So we're going to do integration by parts again. For this integral right here, we're going to put the e in the same spot we did before. So t will go there, and the derivative of t is 1 e to the 2t over 2. And then again, we're going to go across and diagonally down. So what am I getting for the integral of t squared e to the 2t? Make sure you don't forget about the minus here. It applies to both terms. Across minus. And now, looking at the integral we're left with, there's no t anymore left. There's no polynomial, so I can just use substitution to compute that integral. And put a plus c on the end of my answer. So now we're going to switch gears a little bit. We're going to go to doing a trig integral. So let's look at our last example for this video. Let's evaluate the integral of sine to the 5th cosine to the 4th. Now this is an integral that has sines and cosines in it, and remember when we learned this, sine and cosines, there were rules on how we integrate. And so remember the first rule said if m and n, or m or n, if one of them, you need to use substitution. And so if you look in ours, our power of sine is odd, so we're going to use a substitution here. So what you're going to do is take the one that has an odd power, which is sine, and you're going to pull off one. So it'll be sine to the 4th, cosine to the 4th, and then a sine at the end. Okay. And now, what we're going to do is going to take the rest of the sines that were left, and you're going to write them in terms of cosine. So, first thing I'm going to do is view this as sine squared squared. And then I can replace sine squared with 1 minus cosine squared. And now we're going to do a substitution, a u substitution. U is going to be cosine. The derivative of cosine is a minus sine. So we're going to get a minus 1 minus u squared squared, u to the 4th, du. So you're actually going to have to FOIL this part out right here. If you FOIL that out, 1 minus 2u squared plus u to the 4th. Distribute the u to the 4th to get rid of that multiplication. And now I just have a polynomial. Do your reverse power rule. Negative u to the 5th over 5 minus 2u to the 7th over 7 plus c. And then plug in for u was cosine, so it'll be minus cosine to the 5th plus 2 cosine to the 7th minus cosine to the 9th over 9 plus c. And there's my answer.